Hello everybody, this is Ramesh Pani. In this video, we can talk about synthetic division. To find the quotient and remainder when a polynomial of degree 1 or higher is divided by x minus c, a shortened version of long division called synthetic division. Look at this example. X squared plus 3x minus 2 divided by x plus 1 gives the quotient x plus 2, remainder negative 4. Dividend over divisor equals quotient plus remainder over divisor. Dividend is x squared plus 3x minus 2. Divisor is x plus 1 equals quotient is x plus 2. Remainder is negative 4. Divisor is x plus 1. We are dividing x squared plus 3x minus 2 by x plus 1. So in the form x minus c equal to negative 1, x plus 1 is represented by negative 1. Now these numbers are the coefficient of the polynomial. The coefficient of x squared is 1, coefficient of x is plus 3, and the constant is negative 2. And this negative 1 we got by writing x plus 1 in this format, so we'll get negative 1. After that, draw a line, then bring down the first number below the line. Then multiply this negative 1 with this number, we'll get negative 1, and write down under 3, not under 1. Then add these 2, we'll get 2. That result you write down below the line. Again, repeat the same process. That means multiplying this 2 with negative 1, we'll get negative 1 times 2 is negative 2. We'll write under negative 2. Then you add them, we'll get negative 4. Write it below the line. The quotient is found in the bottom row. The degree of a quotient polynomial is 1 less than the degree of the dividend. Here the dividend, whose degree is 2, look at here, the degree is 2 here because the highest exponent is 2 here, so degree is 2. So the quotient will be the degree 1 because 1 less than the degree of the dividend. So this will be degree 1. That means the quotient polynomial will be x plus 2, whose degree is 1, and the remainder will be negative 4. Some helpful hint: before dividing by synthetic division, write the dividend in descending order of variable exponent. Descending means highest and gradually to lowest. Any missing powers of the variable should be represented by 0 times the variable raised to the missing power. That means, look at this example. Here x cube x plus 1. After x cube, the degree 3, there should be x square, but x square is missing. So whenever we will go for synthetic division, we have to rewrite this in this formula: x cube plus 0 times x square plus x plus 1. Look at here, we are writing by 0 times the variable raised to the missing power, this one. So using synthetic division to divide 3 minus x plus 2x cube by x minus 2. First you have to order in descending order. Means first 2x cube will come, then x square, then x, then 3. Here x square is not there, so in that place we will have to write 0. The coefficient of x cube is 2, so write 2. Then there should be x square. Because x square is not here, so the coefficient will be 0. Then x, the coefficient of x is -1. Then constant, and x minus 2 is represented by 2 here. The same process how you did in earlier example. Bring down the first number below the line, then this number multiplied with this will get 4. Write down under 0, add them, will get 4. Write it below the line. Again this number multiplied with 2 will get 8. Write down under -1, add them, will get 7. Then 7 multiplied with 2 will get 14. Write down under 3 and add them, 17. Okay. After that, what is the degree of this polynomial? It's a cube, so degree of the polynomial is 3, and the quotient polynomial degree will be 2, because we discussed earlier it will be 1 less than the degree of the dividend. So if it is 3, means 3 is the degree of the dividend polynomial, the quotient polynomial will be degree 2, means 3 minus 1 equal to 2. So then the degree 2 means this will be 2x square 4x plus 7, that will be the quotient polynomial, and this 17 is your remainder. So finally we can write 2x cubed minus x plus 3 over x minus 2 equal to 2x square plus 4x plus 7 plus the remainder is 17 over the divisor. The divisor is x minus 2. Remainder theorem. If polynomial px is divided by x minus c, then the remainder is p of c. Let us will apply this statement in our polynomial. Remainder theorem. Use the remainder theorem and synthetic division to find p of 4. Let us we divide this, then we'll see how much remainder, and that will be the remainder for this polynomial. Now write down 4 here because they are asking P of 4. Then write all the coefficient. Now look at here, this polynomial is in descending order and all the variables are present except x. That means the coefficient will be 0. So now write down 1, the coefficient x square, x to the 4, negative 1, coefficient of x cubed, negative 2, coefficient x square, 0, coefficient of x, and 1 the constant. After writing these, bring down the number 1 below the line and multiply this 4 with 1. After multiplying, you write down this 4 below negative 1. Then add them. We'll get 3. Again this 3 multiplied 4 will get 12. You add them and we'll get 10. Again this 10 you multiply with 4, then we get 40. You just add them, 40 with 0, and we get 40. Again this 40 multiply with 4, you write down under 1 and add them, you get 161. So what is the remainder then? P of 4 is 161. Thank you.